Dear students, welcome to today's class. In the last few classes, we have explained different types of functions. We have explained. Actually, there are still some more functions are remains. So before explaining them, here in this class, I am going to teach a very interesting topic, that is number of functions from A to B. So in this video, I am going to explain about number of functions, number of one functions, number of onto functions, number of into functions, and number of bijections. Okay, now all those things in this video I am trying to cover. Okay, so let us start our class. So here the number of elements in the set A is n. Don't confuse this n and this is, for my convenience sake, I am taking the set A contains n distinct element and the set B contains m distinct element. Then the number of functions from A to B are m to the power of n, or to remember easily, n of B to the power of n of A. That means the number of elements in B to the power of number of elements in A. If it is A to B, B to the power of A. If it is A to B, if it is B to A to the power of B. That way you can remember. So let us see the proof. Proof is very easy. So if you know the knowledge of permutations and combinations, already we cover some topics there. So if you know the knowledge of permutations and combinations, the principle of multiplication and principle of addition, this proof is very easy. Okay. So on the whole, what are they? Here there are two sets are there. So the set A and the set B. A and B, and already f is a function from A to B. That means every element of A have a unique image in B. So in A there are n elements are there. Let the elements be A1, A2, A3, so on, AN. In B there are m elements are there. They are B1, B2, B3, so on, Bm. So in A, n elements are there. In B, m elements are there. Okay, now. So what is a function? Every element of A have a unique image in B. Okay, now. That means what? Here, A1 can be associated any one of the elements of M. Any one of the elements of M. That means what? A1, but one element cannot be associated with two elements. Remember that. A1 can associate with B1, A1 can associate with B2, A1 can associate with B3, A1 can associate with M. That means how many chances are there that A1 can associate? Means there are m chances are there. That means A1 can associate in how many ways? M ways. Okay, right. Next, A2 can associate in how many ways to make a function A2? First I am telling A2. A2 also can associate in m ways. Why? Because see here, if there are two elements are there, A, B, 1, 2, 3, A can associate with 1 and B also can associate with 1. Still it is a function. So that means two elements can associate with 1. Two elements can have one image, but one element cannot have two images. Okay. Right. So that's why A2 also can have how many ways? M ways. So therefore A2 can associate or mapped onto in how many ways? M ways. M ways. Like that, so on. A3 can associate in how many ways? M ways. A3 also M ways. So on. A can associate in how many ways? M ways. Now, in the permutations and combinations, we will have the fundamental principle of multiplication. That means, if a work is done in m ways, another work is done in n ways, both the works can be done simultaneously in m into n ways. Here, to make a function from A to B, all the elements of A should be associated with a unique element of B. All the elements of A. That means how many elements are there? N elements are there. N elements can be associated with any element, all should be happen compulsory. That means what? Principle of multiplication will have. That means to make a function, how many ways are there? So this is a m ways. That means a can be associated in m ways, and means what? Compulsory a2 also should associate. That means a2 can associate in m ways, and a3 can associate in how many ways? How a3 can be mapped onto the elements in b, how many ways? M ways. Like that here, and compulsory to make a function from a to b, all the elements of a should be associated with the elements of b, and means what? Into. Or means plus, that is principle of addition. Now from the point of view of the principle of multiplication, so therefore to make a function from a to b, the number of ways are how many? M into so on m. So these are how many ways are there? So this is a 1, this is a 2, this is a 3, this is how much? N. Therefore n. So m into m square, m into m cube. So m is written in how many ways? N times, therefore m power n. So this is according to the principle of multiplication. Understand this? Okay, right. If a to b, then the number of functions are n of b to the power of n of a. If b to a, then the number of functions are n of a to the power of n of b. Easily you can remember this formula, simply codomain to the power of domain. Simply you can remember this formula. For example, if f is a function from a to b, then the number of functions means b power a. Simply you remember that b power a. That means n of b to the power of n of a. If f is a function from a to d, number of functions are d power a. Codomain to the power of domain. That means number of elements in codomain to the power of number of elements in domain. So here we are applied the principle of multiplication. Understand? So I hope that you understand this proof. Now let us go for number of 1 functions. Dear students, welcome to number of 1 functions. If n of a is equal to n, so that means here don't get confused with this n and n. For my convenience sake, I am saying that a contains n elements and b contains m elements, then the number of 1 functions from a to b are mpn, where p is a permutations here. If m is greater than or equal to n, simply 0 if m is less than n, of when n is greater than m, right? So before explaining this, I am going to briefly explain what is 1 function, right? Let a and b be two non-empty set. Let f is a function from a to b. Let the number of elements, the elements in a is 1, 2, 3, 4, and b contains the elements some a, b, c, d, e, f, g, h, like this. So to make a f from a to b, let us say that 1 is associated with a. 1 is associated with a. And 2 is should be associated with either b or c or d or e or f or g. Understand this? 2 cannot be associated with a. Why? Because already the berth a is confirmed. Berth a is confirmed by the passenger a. You cannot confirm a. Already it is over. Just like in a bus, 1 seat, 1 passenger. Here the passengers, here the number of seats. Already seat A is reserved by 1, passenger 1. Therefore, how many seats remain means, if there are n seats are there, n minus 1 seats are remained for 2. That means for 2 we have, A has 1, 2, 3, 4, 5, 6, 7, 8. 8 chances are there. 8 seats are available for 1. But for 2, there are only 7 seats are available. That means already 1 seat is reserved, right? For 3, how many seats are reserved? 3 cannot reserve A and B. Why? Because already they are reserved, 1 function. So 3 have chances C, D, E, F. That means 1 have the chance. 1, 2, 3, 4, 5, 6, 7, 8 chances are there. 8 possible ways are there. A can be, 1 can be filled with how many ways? 8 ways. For 2, it is 7 ways. For 3, it is 6 ways. For 4, it is, for 4, how many chances are there? 4 can be either take D or E or F or G or H. Therefore, 4 has any chance. That means, try to understand here. Before 1 function, 2 can be associated with A also. 2 can be associated with A. But here, since it before functions in the functions concept, but in 1 function, 1 element should be associated with 1. So, as per second, third, fourth, 1 chances will be going on missing, going on less. Okay, now. So, if you understand this concept, the proof of that is a very, very easy one. Okay. So, let us see the proof. See here. A and B are 2 sets, 2 non-empty sets. A has the elements A1, A2, A3, so on, An. B has the elements B1, B2, B3, so on, Bm. Understand? F is a function from A to B. So, to become, if F from A to B is 1, 1, if it is A to B is 1, 1, A1 can associate in m ways. A1 can associate in how many ways? There are how many elements are there? M elements are there. A2 can associate in m1 m minus 1 ways. Understand? Before in functions it is also m ways. A3 can associate in m minus 2 ways. So on. The last one is An can associate in how many ways? That is important. That is important. This point is important. See here, A1 can associate in m ways. A2 can associate in how many ways? M minus 1, 1. A3 can associate in how many ways? M minus 2. If it is 3, here you are getting 2. If it is 4, M minus 3. If it is 5, M minus 4. That means 1, 1, 1 element is going on reducing. So, An can be associated in M minus of n minus 1 ways. Remember this. M minus of n minus 1 ways. So, all together how many are there? M ways. Okay, na? Right. So, if A3 is there, how many is there? A minus 2, 2 is there. If it is A4, M minus 3. If it is An is there, An is there. So, the element, last element An can be associated in how many ways? M minus of n minus 1 ways. Right. So, according to the fundamental principle of multiplication. According to the fundamental principle of multiplication from A to B. So, the number of 1, 1 functions are, so according to the fundamental principle of multiplication, so to make A from A to B as a 1, 1 function, all these should be happen, all these operations should be happen, must and should. That means, and means what? Multiplication, that is m into m minus 1 into m minus 2 into so on, m minus of n minus 1. M into m minus 1 into m minus 2 into so on, m minus of n minus 1. This is nothing but MPN. MPN. Understand? MPN. Otherwise, you can calculate m factorial by m minus n factorial. You will get this only. Understand this? So, so like that we can get the formula. Otherwise, I will tell sir how many immediately how can you get right this sir means a very simple example I will write down. Let us see that what is the value of 6p4 value, otherwise 6p2 value. 6p2 value is how much? Is 6 factorial by 6 minus 2 factorial. That is 6 factorial by 4 factorial. That means 6 into 5 into 4 factorial by 4 factorial. That means 6 into 5. That is 6 into 5. Can I write down 6 minus 1? This 5 can I write down? This 4 factorial gets cancelled on the wall. 6p2 means 6 into 5. This 5 can I write down 6 minus 1? That means 6p2 value is equal to how much? 6 into 6 minus 1. Here if it is 2 is there, here 1 is there. If it is 1, here you are getting 2. Like that, if it is n minus 1, you have to get n here. Understand? Once again I am telling, 6p2 value is 6 into 5. Clearly, shortcut. That means 6 into 5. 5 means how much can I write down? 6 minus 1. That means 6p2 value is 6 into 6 minus 1. If it is a 1 is there, here how much should be there? 2. Like that, m into m minus 1, reducing, go on. How much you are reducing? M minus of n minus 1. That means this can be written in terms of notation, that is mpn. Understand? Okay, very easy. So that is if m greater than or equal to n, this is the situation. Why? So to define mpn, m should be greater than or equal to n. If it is m is less than n, what happens? Let us see this. To make you understand this, a very small example I will take here. So this is equal to 1, 2, 3, 4. Here 1, 2, 3. Here element A and it is B. F is a function from A to B. So here n is equal to how much? 4 and m is equal to 3. So here m is less than n, clearly. So here let us say 1 is attached to A, let us call it as ABC. Okay, now let us 1 is associated with A. 2 is associated, to make it as a 1 function, 2 should be associated with any one of the B or C. Let us say 3 is associated with C. Now what about 4? 4 is become alone, no association, no lover. So 4 has nothing. All 3 students, they got 3 things, but what about the 4th student? He didn't have to. But if it is a function, already he has to select one of the selected elements. That means it cannot be a 1 function. It is simply a function. It's simply a function. Otherwise, we can say that it is an onto function. Understand this? Okay. Therefore, here the number of 1 functions are 0. If it is m is less than n, then the number of onto functions is 0. So this can be easily we can identify. Understand this? Okay. I hope that you understand this proof. Let us go for number of onto functions. It's a very easy function chapter, but you should be very careful to define number of onto functions. Okay, now right. Dear students, before explaining this number of onto functions theorem proof, let me explain about a concept is there in permutation and combination, that is a principle of inclusion and exclusion. This already you know this formula, in the sets also we come across. So here n of A union B is equal to n of A plus n of B minus n of A intersection B. So that means the number of elements present in A union B, that means the number of elements present in either A or B is equal to n of A. This is the number of elements in A. That means you are counting A intersection B, remember, plus n of B. You are again counting, you are again considering this A intersection B part. That means you are counting the number of elements in A intersection B in A and in B. That means you are counting 2 times. But here the question is the number of elements present in either A or B. So that's why, but if you are counting 2 times, that's why you have to subtract 1 time, that is minus n of A intersection B, right? If 3 sets are there, same principle apply here. So the number of elements present in A union B union C is equal to, that means number of elements present in A or B or C is equal to. The formula is well known formula, that is n of A plus n of B plus n of C minus n of N. That means what? N of A means, see here, this is a n of A plus n of B. That means you are counting A intersection B 2 times, 2 times. That's why you are subtracted 1 time. Like that, B and C, you are counting B intersection C double time. That's why you are subtracting. While you are subtracting, you are first time you subtracted, second time you subtracted, third time, but you are not counting A intersection B intersection C. That's why you have to add A intersection B intersection C. Okay now. So from this, what how to say? So this is the number of elements present in one single set minus double set A and B, 2 sets. Here also n of A plus n of B plus n of C, single set, minus A intersection B minus B intersection C minus A intersection C, double sets, minus. Again plus. From this what? First plus, 2 sets minus, 3 set plus. Here also single set n of A, n of B, n of C, plus double set minus, triple set plus, again 4 sets minus, plus minus plus minus will come. Now this is the generalized form of this principle of inclusive and exclusive. The thing is here n of A1 union A2 union AN. Here only I have taken 2 sets, here I have taken 3 sets, but here I am taking n sets. Now the formula is sigma n AI. That means n of A plus n of B plus n of C plus n of AN minus 2 sets, A1 intersection A2, A2 intersection A3, again A1 intersection, all possible 2 sets you will get here, plus 3 sets, minus 4 sets, so on, minus 1 whole power, and it will be continue up to the number of elements present in. So here only 2 elements are there, A intersection B, and here 3 elements are there, A intersection B intersection C is and. Okay. So if you know this principle of inclusion and exclusion, this proof of the onto function will be very, very easy one. Okay. So let us start this proof. Okay now. Right. So dear students, welcome to the proof of number of onto functions. Okay now. Right. If n of A contains n elements, n of B contains A contains n elements and B contains m elements, then the number of onto functions from A to B is equal to m to the power of n minus mc1 m minus 1 whole power n plus mc2 m minus 2 whole power n, so on. So by seeing this proof, you will get something mad. Sir, what these are all these proofs? Nothing. You may like that. But if you understand this conceptually, the problem is very, very easy. But the thing is, you should have some fundamental knowledge in permutations and combinations. Actually, it belongs to permutations and combinations chapter. Okay, na? Right. First thing, to know onto function, we should know that into function. About into function also you should know. That means f is 1, 2, 3, 4, 5, 6, 7. 1 is mapped onto 4. Let us say that 2 is mapped onto 5, 3 is mapped onto 6. If at all, at least if one element is there which is not mapped onto A, any element of A, then it is called into function. We call it as into function. Understand this? We call it as into function, right? That means what? If at least one element is present in B, then that function is called into function. That means if you want to find out onto function, if you want to find out number of onto function, from the total number of functions, if you subtract into functions, number of into functions, you will get the onto functions. That means if you want to find out total number of onto functions, then you have to find out from the total number of functions from A to B, you have to subtract into functions. Understand this? The problem will be over. Then how to do this? onto functions is equal to total number of functions minus into functions. Otherwise, if you want to find out into functions, so total number of functions minus onto function. That means either a function is either into or onto. Okay, now, so let us start our proof. So dear students, let us see here, there are two sets are there. One set is A, another set is B. So this is f is a function from A to B. Let us take these elements as A1, A2, A3, so on, An. Let us take the elements in B as B1, B2, B3, so on, Bm. Okay, that's. So we are up from the beginning, we are taking like this only. Now I am going to see that number of onto functions. Number of onto functions. Okay, now from A to B, of course. This is equal to total number of functions minus number of into functions. Number of into functions. Okay, now, right. That is very clear. Now, total number of functions are how many? Already it is over. The theorem is over. Total number of functions from A to B. Total number of functions from A to B are how many? M to the power of n. That is m to the power of n minus, be careful here. So from here onwards, our real concept is going. Don't get confused here. Be careful here. Number of into functions. Number of into functions. Okay, now, right. Minus number of into functions. Okay, now please remember this principle of inclusion and exclusion. First, let us say that to make into a into function, let us say that the element B1 is free here. Let us say that the element B1 is free. It is free. It is not attached to or not associated to any element of A. Then can it become an into function? Yes. So all these A1, A2, A3 are attached to B1, B2, B3, Bm. Understand? Forget about B1. B1 is alone. B1 is alone. It is not talking with anybody. So B1 is alone. Therefore, the number of into functions. Then is it a into function? Yes, it is an into function. Then how many functions you will get here? So if B1 is left over, how many elements will be there? How many elements will be there? Here total m elements are there. The element B1 is not, it is not at all participating now. Therefore, how many elements are there? M minus 1 elements will be there. M minus 1. Here how many elements will be there? N elements will be there. Therefore, total number of all functions will become into functions. Why? Because B1 is not associated. So, total number of functions are how many? M minus 1 to the power of n. M minus 1 to the power of n. Like that. Now, this can be done. You can select B1 or B2 or B3 or Bm, any one of the element. If B1 or B2, if it is B2 is there, same concept. If it is B3 is allowed, same concept. If B4 is allowed, same concept. That means out of these m elements, one element can be selected in how many ways? That is MC one ways. Understand? Okay. Next comes what? Minus. One element is over. One element. See here. Starting one element plus, two elements minus, three elements plus, four elements minus. Minus. First starting plus, minus, plus, minus. It's going on like this. So one element is over. Next one. Two elements. B1 and B2. Then we have to say that how many? First of all, functions will be there. How many functions will be there? Already two elements are gone. Let us say that B1 and B2 are alone. B1, B2 are not associated to any elements. So therefore, it is called an into function. So that means how many elements will be there now? M minus 2 elements will be there. So all these n elements are associated with m minus 2 elements. Then number of functions are there, how many? M minus 2 whole power n, but actually they are into functions. B1, B2 are not participating, that is m minus 2 whole power n. 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 So, right. Now, out of all these by B1, B2, B3, B4, Bm, how many ways you can select B1 and B2? B1, B2. How many ways you can select B1, B2? That means B2, B3 also you can select. See here, B1, B2 you can select. B2, B3 also you can select. That means you are selecting B2 two times, no? Two times you are selecting, no? That's why. So here becomes the principle of inclusion there. Understand this? Right. So that is here MC1. So here out of all these m elements, you have to select two elements. That is, this can be done in how many ways? MC2 ways. MC2 ways. Okay, two elements. Next what comes? Three elements. Then it will becomes plus. See here, n of A union B union C is equal to n of A plus n of B plus n of C minus n of A intersection B intersection C plus n of A intersection B intersection plus I will come. General form also I told. So here let us say that B1, B2, B3 are not participating. They are not associated to the elements of A. So here how many elements will be there? M minus 3 elements will be there. Then B1, B2, B3 are not participating. So all this will come attached to this m minus 3. Their total number of functions will be there how much? M minus 3 whole to the power of n. So total m elements are there. Out of these m elements, 3 elements, either A B1, B2, B3 or B2, B3, B4 or B2, B3, B5 or B2, B3, B7, whatever may be there, can be selected in how many ways? MC3 ways. Minus it will go on up to where? When MC1, MC2, MC3 up to MCM will come, no? Up to that. Why? Because all should be completed, no? All should be completed. That means no element MCM. Okay, now? Right. So this is so on will be there. Understand this concept? So this is a total number of into functions. Total number of into functions. This is total number of functions. From total number of functions, if you subtract total number of into functions. Understand this, why you have taken plus, minus, plus, minus. This is according to the principle of inclusion and exclusion. N of A, this is all one A, N of A, N of B, N of C. This is minus N of A intersection B and minus A B intersection C minus A intersection C. Again this plus N of A intersection B intersection C. This is plus, right? So your formula is m power n minus mc1 m minus 1 whole power n plus mc2 m minus 2 whole power n minus mc3 m minus 3 whole power n. It will be so on. Understand this? So this is the formula there we are getting. Understand this? So this is the formula of finding onto function. Sir, this you are writing so on, sir, up to where means that depends upon the number of elements in A and B. So we will do some formula problems regarding this. We can came to know that, for example, for example, n greater than or equal to m. That means then it will become 0. That also I will show the second part of this. When n less than m, the number of onto functions are 0. That I will show in a small example. Understand this? I hope that you understand this proof. Dear students, so try to understand this part. The second part is, if n is less than m, what happens? See here, n is less than m. Here A and B. Here 1, 2. Here A, B, C, D elements are there. Okay. So here how many elements are there? 2. Here how many elements are there? 4. Here n is less than m. Now to make an onto function, let us 1 is attached to A, 2 is associated with to B. Then how can you say what about C and D? They are not associated to any element of the pair. If at all, if you want to associate 2 from C, that cannot be a function. Okay. So therefore, it is a number of onto functions are 0. If n is less than m, then the number of onto functions are 0. Okay, now if n is greater than or equal to m, the formula will apply. Okay, now I hope that you completely understand this concept. We will do the number of problems on onto functions. Okay, now so let us go for next concept. Welcome to next theorem. If n of a is equal to n of b is equal to n, then the number of bijections from a to b is n factorial. Very easy. Already we know that to make a bijection, the number of elements in a should be equal to the number of elements in b. So very easy one. So bijection means both 1, 1 and onto. So let us say that 1, 2, 3, a, b, c. 1 is mapped onto 2, 2 is mapped onto b, 3 is mapped onto c here. That means a have 3 elements and b also have 3 elements. Therefore, there exists a 1, 1 and onto. Therefore, number of functions are bijections. Number of say here all are bijections. Now, how many bijections we will get? Let us see that. That is given by n factorial. So very easy concept here. See here. Let us take that a and b. There are 2 sets, and here f is a function from a to b. So let us take a1, a2, a3, so on, an. This is b1, b2, b3, so on, bn. Be remember here, bn, n elements. An is bn, bn. There in the previous theorems we have taken bm, right? Very easy one, very easy one. Just like we will go proceed in the format of just like a functions. Right, a1 can be associated. A1 can be associated in how many ways? N ways. In how many ways? N ways. Why? Because here how many elements are there? N elements. The element A2 can be associated or mapped onto the elements of B. In how many ways? Already one element is reserved by A1. Already B1 is reserved by A1. There how many elements remains? N minus 1 elements remains. Understand? A3 can be mapped onto or associated to. If A3, about A3, if it is, let us say that A2 is associated with B2, already 2 seats are reserved. 2 seats are reserved. How many seats remains? N minus 2. So if you go on, last an element, so this is associated to this is associated to this. So ultimately last element an is there, no? Last seat, that is 1. Before that 3. Before that, for an minus 1, there will be 2 seats reserved. For an minus 2, 3 seats will be reserved. For last passenger A1, the final seat, that is the last seat, window seat, that will be there, that is 1. So altogether number of bijections is equal to, that means what, to make it is a function, all this should be happened. If all passengers came, then only the bus will start. All should come, all must and should come. Understand this? That means what, we have to use the principle of multiplication. That means multiplication means what? Into. Into means what? N into n minus 1 into n minus 2 into so on, 3 into 2 into 1. This is nothing but n factorial. That is nothing but n factorial. So this is the proof of bijections. So dear students, in this class today we have learned about what is number of functions, number of 1, 1 functions, number of many 1 functions are also. If you know the number of 1, 1 functions, so total number of functions minus number of 1, 1 functions will give the number of many 1 functions. Understand this? So that means number of functions, number of 1, 1 functions, number of many 1 functions, number of onto functions, number of into functions also. If you know the number of onto functions, you can find out the number of into functions. Okay. So total number of functions minus into functions will give onto functions. Total number of functions minus onto functions will give into functions. And the last and final, the number of bijection proofs are also there. So I hope that you enjoyed today's class. In the tomorrow's class, So we are going to start some few problems on these concepts. Okay na? So until then, all the best.